my dear students. You all must be well at your place and studying physics regularly. Today, this video is about upthrust and Archimedes principle. Let us see what we are going to cover up in this video. Buoyancy and upthrust, characteristic properties of upthrust, reason and derivation of formula for upthrust, Archimedes principle, experimental verification of it, flotation of solid bodies with a given density in liquids. Let us first understand what is buoyancy and upthrust. You can see in this picture, the boy is pushing a ball inside water unsuccessfully. That is, when the boy lifts his hand, he leaves the ball comes up with a force. What is the reason? What is the force which is pushing the ball in the upward direction? So children, this is buoyant force. It is the characteristic property of the liquid. A liquid applies an upward force on a body when the body is partially or fully immersed in the liquid. This force is called buoyant force or upthrust. If I divide this word upthrust in two, then thrust is the perpendicular force which is applied in the upward direction. Buoyancy is the phenomena under which we study the buoyant force. It is the property of the liquid to exert the upward force on the body immersed in it. This property of the liquid is called buoyancy. Now, what are the characteristic properties of upthrust? For a larger volume of the body, upthrust will be more. If you will try to push a bigger object inside, bigger, I'm not saying heavier, bigger, volume should be more. Inside a liquid, more upthrust will be experienced. More is the density of the fluid, greater is the upthrust. Since upthrust is the characteristic property of the fluid, of the liquid. Therefore, it is not specially liquid. Gases also show upthrust. So we should use the word fluid. Density of the fluid is more, upthrust will be more. For example, I will take glycerine and water. Glycerine is denser than water. So glycerine will apply more upthrust on the objects. It is very difficult to immerse objects inside glycerine, and it is easy in comparison to this. It is easy to immerse the objects in water. Now, upthrust acts on a body in the upward direction at the center of gravity of the body. You must be knowing center of gravity. See the point where the whole mass of the body appears to act, and we can balance the body at this point. If I draw this rectangle, let us consider we have a rectangular book. Then you must have seen that this book can be balanced at this point. You must have seen people swirling the book on their finger by holding the book exactly at the center. This point is called center of gravity, where the body can be balanced. And this point becomes the center of buoyancy also when this body is completely immersed inside the liquid. What is the symbol for buoyant force? It is capital F subscript B. And the unit is, SI unit is Newton, gravitational unit is kgf, kilogram force. Now, let us study the condition for a body to float or sink in fluid. If buoyant force is greater than weight of the body, or buoyant force is equal to the weight of the body will float. If buoyant force is less than the weight of the body will sink. Let us see here. For the body to float, the buoyant force should be greater than the weight of the object. See here, positive buoyancy. In this, the ball is lighter than the liquid, density of the liquid. Density we will talk later. Here, let us talk of the two forces. One force which the water is applying in the upward direction called the buoyant force, and the other force is the weight of the body which is acting in the downward direction. Since the weight of the body is less, buoyant force is more, so you see only a small part of the body to be immersed inside the liquid. Second case, weight of the body is more, acting in the downward direction as compared to this, and buoyant force remains the same liquid, same amount of liquid we have taken. So in this case, you see majority of the volume of the body to be inside the liquid. Therefore, this is the case when buoyant force, weight of the body is greater. Weight of the body is greater, or you consider here, let us consider both to be almost same. So the body is still floating but completely immersed. Floating but slightly the part is more. Here you see the fourth example. In this case, we have the body floating in the with its whole volume inside the liquid because weight of the body and buoyant force are equal. Now, the case where the weight of the body is more and the buoyant force is less, you see the body immersing completely, it is sinking, it is resting on the floor of the container, bottom of the container. So one more thing, for a floating body, the net force acting downwards, that is the apparent weight, is 0. When the weight of the body and the buoyant force are equal, in that case, the apparent weight of the body is 0. That means here it will appear that the body has no weight. Then what is the effect of upthrust? The effect of upthrust is that the weight of the body immersed in the liquid appears to be less than its actual weight. You can see the actual weight is 500 millinewton, but here it is only 300. So why? Because rest of the weight is balanced by the upthrust. What are the factors affecting upthrust? Two factors are there affecting upthrust: volume of the body submerged and density of the liquid. So we can say that upthrust is equal to volume of the body submerged in the liquid multiplied by density of the liquid. Let us derive a formula for upthrust, that is its mathematical proof. Consider this container present inside this liquid, which is shown by blue color. The container is at a height h1, the upper surface of the container is at a height h1 from the free surface of the liquid, and the lower surface, flat surface of the container is at a height h2 from the upper surface, free surface of the liquid. So what is the net height? It is h2 minus h1. Therefore, the buoyant force will be due to this much F2 minus F1. F2 minus F1. This much height of the liquid will apply the buoyant force. Let us calculate it. FB buoyant force is equal to F2 minus F1. Now what is F2? If the pressure acting on the second surface is P2, then we know that pressure is equal to force upon area. And you can write it as, what is the equation for force? Force will be equal to pressure into area. Now what is the pressure applied by a liquid column? It is equal to height of the liquid column multiplied by density of the liquid column multiplied by G. So that is equal to H rho G. Therefore, in place of pressure, we have written H rho G. H rho G into area minus H1 rho G into area. So how much is the force acting on this surface? It is H1 rho G into area. Area is considered to be same for both the surfaces. solving it further, you take out A common. So A H2 minus H1 rho G. Now here this A into the height, that is area of this surface into the height of the container will give you the volume of the container. So you have written A into H2 minus H1 is equal to V. V is the volume of the cylinder submerged in the liquid. Therefore, children, what is the resultant upward thrust on this body? The resultant upward thrust is equal to V rho G. This is how we can prove it. And that is also equal to weight of the liquid displaced. How can you convert it equal to weight? You know that volume into density is equal to mass. Volume into density is equal to mass of this cylinder. And mass into gravity, if in place of V rho I write M, that M into G is equal to the weight of the body. So this container, when it is immersed in water, it will displace liquid equal to its own weight. Upthrust will be also equal to weight of the liquid displaced by this container. Now let us study Archimedes principle. Archimedes principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust which is equal to weight of the liquid displaced by it. Look at the figure. One finger immersed, weight of the liquid displaced is very less. 2, weight of the liquid displaced is more. How will you find weight of the liquid displaced here? Just see the rise in the level of the liquid. And here, when all the 4 fingers, the full hand is immersed, in that case, the liquid overflows the container. Because how much liquid will be displaced? It will be equal to the weight of the body, the object which is displaced, which is immersed in that liquid. So Archimedes principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust which is equal to weight of the liquid displaced by it. So here, how much upthrust this body will experience? Find out the weight of this liquid displaced. Weight is also a force, upthrust is also a force. So we can say the body will experience an upthrust equal to weight of the liquid displaced. Let us have a mathematical proof for it. For experimental verification, we will use this experiment. Let us do this experiment. Archimedes principle, this is the person. These are the materials which you require to do the experiment. A Eureka can. Because of this outlet, it is called Eureka can. We need a stone, beakers, measuring jar, and a spring balance. Spring balance measures the weight of the object. Pour some liquid in the Eureka can. Then replace the beaker by another beaker of known mass. Here we should know the mass of the beaker. Now tie a stone with a thread and tie it with the hook of the spring balance. What is the weight of the stone in air? It is 20 gram force. Put this stone with the help of the spring balance inside water. Now what is the weight of the stone? It is 17 gram force. And you see some liquid displaced in the container. Okay, we calculated the weight of the water, weight of the stone in air, and weight of stone in water. Difference is 3 gram force. So how much is the apparent loss of weight? Apparent means which is not real. Why did we feel that loss of weight? Because we immersed the stone inside the liquid. So we call it apparent loss. Apparent loss of weight is equal to 3 gram force. Okay. Now, pour this liquid which we had collected in the smaller container in a measuring jar. What do you observe? We observe that the volume of the water is 3 centimeter cube. 3 centimeter cube. Okay. Now, how much is 3 centimeter cube in terms of gram force? 3 centimeter cube, 3 cc is equal to 3 gram force. What is the reason? Because water has a density of, at 4 degrees Celsius, density of water is 1 gram per centimeter cube. So we can consider 1 centimeter cube is equal to 1 gram force. Therefore, weight of the water displaced is how much? 3 gram force. And thus, that is equal to weight of the water displaced is equal to the apparent loss of weight of the stone. So this is how we have verified the Archimedes principle. What does it say? It says that when a body is immersed partially or completely in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by the body. So this was the apparent weight of the body when it was immersed in the liquid, and then this is same as the weight of the liquid displaced, and apparent weight is equal to the buoyant force. Apparent weight of the body is equal to buoyant force. Thank you, children. This is all that we have to study in this.